Home plate for tonight is only 6 problems, only. And it says, home plate, number 1 and 2 represent 4 ways. 7 minus -2, and number 2 is -3 minus 5. Number 3, simplify. 3 plus 9 plus 1 plus 7, minus 2 minus 4 minus 3 plus 8, minus -1. And numbers 4, 5, and 6, it says multiply and divide. 4 is -15 times 12. 5 is -49 times -57. And number 6 is 2/3 divided by -4 over 12. That's a home plate for tonight. Copy that. All right, Tony, can you read us the objective, please? Did everybody hear that? Okay, one more time, please. Let's read it together. 1, 2, 3. So on the screen you don't see it because it should be on the board. But now let me forward the screen. And there's our objective. And of course our concept for today is what, everyone? Everyone? Real numbers. That is correct. So once you copy the objective at the bottom left, bless you, of your Cornell notes, what goes in the center of your Freyer model? Real numbers. Is that correct? Real numbers. So, in the center of your Freyer model, write real numbers. And without looking at your notes, see if you can fill out the Freyer model definition, example, non-example, and hashtags. I'll give you some time for that. Ready, go. On your own, please. All right, let's see. Real numbers, the set of all numbers that can be represented by the or on the real number line. Make sure on your definition, even if it's not word by word from what I have, it has to say something to the effect all numbers on the real number line. Real number line. Why is it so specific that we need to write real number line? Because we know that there are other lines, right? So we stated that if these are real numbers, what did we call that one? Everyone? We called it the imaginary, right? Or complex. And you came up with a couple of hashtags, yes? All right. Yes. Hashtag what? Number line, real number line. Hashtag real numbers, yes, I'll take that. Everybody got it? All right. Underneath your Freyer model, I want you to write steps. Write this down. It says, to multiply and divide real numbers, Now, most of us, we all know how to multiply and divide real numbers, yes? But let me show you the first step that I want you to focus on this here. Step 1. Identify if the result is a positive or negative. So this here we're going to focus, before we do any computation, if the result is a positive or negative. And why are we bringing this up first? Because I'm pretty sure, maybe not in this class, I saw it in the movie once, that some students, when they were in 7th grade, they got their papers back and they made a mistake. They forgot to bring down the negative sign. Maybe not in this class, but in that movie that I saw. And why? Because they were worried more about the computation and did all this work, and at the end they forgot to write the little negative sign. This year I want you to flip it. Start with if it's a positive or negative. Now, for multiplication and division, what is the only rule that you should have remembered? If both numbers have the same sign, then the result is a positive. And obviously, if they're not the same sign, the answer has to be what? Negative. That is correct. Once you identify if it's a positive or negative answer, then you do the computation. Step 2, compute the numbers, which means multiply or divide. And at the end, we're going to simplify. Simplify. Copy that. Now, before I continue, look at the last step, simplify. Simplify. Okay, so far what we've been doing up to right now, and I've always only asked to simplify. Think about it. Why haven't I asked you to solve? Think about it first. Why haven't I asked you to solve? Right? Why didn't I write here solve? Why am I only writing simplify? Talk it over your neighbor, see if they know why we only say simplify. Simplify. Let's see. Do we know why we only say simplify? Natalie, what do you think? I'm sorry? Let's see. Step 2, it says compute the numbers. Rachel, why do we say only simplify? Okay. Because we are in expressions only. When do we start solving? When we get to what? Equations. Think last year when they asked you to solve, didn't you solve like for X or for Y or something like that? In this case, we don't solve. So look what we did yesterday. Here, let me show you really quick. Yesterday we did something like this. 3 plus 2. Can we solve this? No, there's nothing to solve. We can simplify it. What is 3 plus 2? We're just making it simpler, aren't we? But what if we have something like this? X plus 3 equals 23. We need to find out what this is. That's when we solve. That's why right now we're not in equations. We are in what? Expressions only. Everybody with me so far? All right. So, with that said, let me go over a couple of these with the steps that I gave you. Writing utensils down, look up. Like I said, this is probably the simplest lesson that you're gonna look at this year. So look up to the score, to the board. It says, step 1, identify if the result is a positive or negative. Look at this one. What is the result for that one? Negative. That's the first thing you do. Now we worry about the numbers. What is 35 divided by 5? 7. Okay. What is the result for this one? What is 11 times 4? 44. Okay. What is the result for this one? Negative 6 times 7? 42. That's what I want you to do. I want you to start changing your set of mind. Instead of doing the computation first, I want you to write the result first. Okay? Because once again, look over there at that poster by the calculus book. You guys see it? Look at all those steps on the left side. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then to the right, another 8 to 10 steps. And then to the right, a graph. Let's say the first step on the left side was this. Look up. Was negative 5 times 6, and then blah, 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 something else. And then you focus more on the computation and you just wrote 30. And then all of a sudden you went to the next step, 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 next step. Oh, and then you did your graph. All right. So then we got that. Well, guess what? If you got this wrong on the first step, guess what happens to the whole thing? Does everybody understand what I'm talking about? Try and focus on the result first, and then you do the computation. Yes? Yes, Mr. Q. Thank you. All right. Next, let me go to this next thing. Give me a second. Reciprocals. Who remembers that word? Okay, some of us. All right. For those that don't remember, it says two numbers are reciprocals if their product is 1. The word product is a result of a multiplication, yes? So watch. If I gave you 1/3, the product of this one and another number should give me a 1. So 1/3 times what gives me 1? Yeah. 3 or 3/1. It's a reciprocal. Why? Because what is 1 times 3? What is 3 times 1? And what is 3/3? 1. What if I gave you 1/5? What is the reciprocal? 5/1, and that gives me 1. What if I gave you 2/4? The reciprocal is 4/2, because this becomes 6/6, which is 1, and so on and so forth. Okay? Now, why am I bringing this up? Because it's imperative that we understand reciprocals when we get to division of fractions. Okay? Because who remembers this in elementary? Okay, kids, today we're going to learn how to divide fractions. Yay. Repeat after me. Keep, change or flip. Some say flip, so this would be, okay, does that sound familiar, kind of? And we've been doing that, and we're really good at doing that. However, why do we do that? No, I'm saying it's easy, but why? What's the reason of flipping it? Because my teacher told me. So when the teacher tells you, go around the mile, bam, it's coming. You guys ready for the mile? Yay. So, let's find out why we do this. We go from here to here. Okay, everybody ready for some algebra? Okay, your attention up here, writing your utensils down. Here we go. I don't want you to be shell-shocked. Here we go. All right, here we go. Let me break this down so you understand it. This says Q is for quotient. Quotient is a word that describes the result of a division. Okay? Or in other words, quotients are also known as fractions. So look, it says, quotients are the set, that's what this bracket stands for, the set of all fractions. Is this a fraction right here? Yes. Quotients are the set of all fractions such that the numerator is an integer. That's what the Z stands for, integer. You guys know what integers are? Counting numbers and their opposites, right? N is an integer, okay? But N cannot equal 0. The denominator cannot equal 0. So that's the definition of fractions. Once again, quotient stands for the result of a division. The Z's stand for integers. which means all these have to be integers, yes? But n cannot equal to 0. Are we there so far? All right? So, let's look at this one. I'm going to show you how to rewrite this one. Do you agree that 1 3/4 divided by 1/2 is 1 3/4 divided by 1/2? Do you agree with that? Okay. Is this a big fraction? Yes, because there's a bar right here, yes? But can we have a fraction over another fraction? According to the definition, a fraction needs to have an integer here and an integer here. Is this an integer? No, it's a fraction. What would be the smallest integer you can think of? 1. How can we make 1/2 into 1? Multiplying it times what? 2 over 1, which is the reciprocal. And whatever we do to the denominator, we do to the numerator. So now that we have that, what is 5 divided by 1? Let me repeat that. What is this divided by 1? 5. Therefore, what is this divided by 1? This whole thing divided by 1 is that. Do you agree with that? And notice, look what happened. Keep, change. So you're looking at me like either you're hungry or you're tired. Yes? All right. So for home play, you already have the you copied earlier. And tomorrow we're going to continue with more algebra stuff. Yay! Have a good one, guys. Enjoy your home play. See you guys tomorrow. Bye.